Hello, everyone. Thank you for joining today's webinar. We're going to give everyone just a few more minutes to join, and then we'll get started. Thank you.
Okay, I'm going to kick things off. Good morning still. This is Fred Bird, and I'm the program manager for Part Supercenter, our Transformers program. Welcome to our webinar. Our Transformers program at PSC, just briefly, we support the legacy GE Transformer products from Pittsfield, Rome, Hickory, Shreveport, and Prolec. We thought, one of the real powers of the PSC is bridging the old technology with the new technology. And embodying that is Nino Pedone, who has 50 years of experience in the transformer market, primarily in the services side, New York City area, the North Bergen shop, the Philadelphia area, the Philly shop. He's supported the PSC for the past 20 years, so he brings a wealth of experience. And if we can capture a half hour of his knowledge, troubleshooting, words of wisdom, things to look out for, it should be very beneficial to our customer base. So welcome, and I'm going to have Nino join us. And I appreciate Nino embracing new technology to bring this webinar to life, and he's promised us in the fourth quarter he'll have a TikTok video out for everybody, so I'll look forward to that. So Nino?
Yes, sir. Good morning,
The
everyone.
floor is yours. Yeah.
And thank you for spending your time with us. From the title of the what we have to speak about, we're going to start with power transformer. First off, I want to clarify one thing. The power transformer does not transform power, but transforms the components of the power. In other words, the electric power, it's a multiplication between the voltage and the current. So what the transformer does, from one winding to another, it changes the components. In other words, if the voltage goes up on one side, the current must go down. On the other side is the opposite. So again, we call it power transformer, but does not transform power, but transforms the component of power. Because again, on every transformer, input power and output power, it's almost the same. As a matter of fact, the transformer is the most efficient amongst the electrical machines, 99.8%, 99.9%. So with this being said, we starting with try to identify what could be happening inside the transformer. Oh, okay, so we know we'll be recording and so forth and so on. Okay, the agenda. What is, again, my presentation, as Fred said, won't last more than 30 minutes, but then we're gonna have a 50 more minutes to discuss if any questions. So what is a Pittsfield transformer? Again, it is a transformer that was built in the Pittsfield plant in Massachusetts in the older 1900. As a matter of fact, we have some records that go even past the 1898. So it's an old factory. It's a lot of records, and there's a lot of information. There's a lot of knowledge in there. So I was lucky enough to be exposed to these through my years with the General Electric Company, and that's what we're talking about. With this being said, let's go to the next step. Like Fred said, Part Supercenter does not cover only transformers, but transformers, large breakers, 13 kV and above, and also low voltage breakers, controls, and any size of motor, DC, vertical motors, all that kind of stuff. So, but again, today we're going to speak only about transformers. Yes. What makes a transformers? I don't care what nation is made. I don't care what is made. It's made the same thing. You got to be a bunch of wire wrapped around a coil, a core, and then on the other side of the core there is another winding. But again, it's copper, it's steel, insulation, cellulose, and so forth and so on. And again, we also have not only oil type transformer, but also dry type transformer, gas filled transformer. The oil only has the purpose of two things: to be increasing the insulation of the conductor and having a means of removing the heat from the windings. And since the hot oil rises for convection motion, the hot oil goes to the top, and then it's got to go through the radiators of the unit, and through the radiators it gets cooled down, then it's go back into cycle. So the oil is the main source for us to know what's happening in our transformer. And again, what we do, we got two ways of taking oil. The first is oil sampling and the gas in oil sampling, two different kind. The first oil sampling gives us a chance to see what kind of, if there is any moisture in the oil, if the oil is degenerating, if the oil's got a sludge or something else. But in this case, we're talking about the dissolved gas analysis, which is much more modern things that test that you know the technical people came up lately. So and let's start first with the high carbon monoxide content. Again, and these, the first test that we said about the overall oil test, it's always recommended at least twice a year, and the gas, so does the gas in oil. So, and that's the only way we have to learn what's happening inside the unit without doing any de-energization or going inside the unit or so forth. So, but again, high carbon monoxide content is the first thing we call. It's an inefficient cooling, overloading. See, all this stuff, it's a consequence of the overheating of the unit. Now, why is the overheating? Could be various things. Overloading, less efficient circulating stuff. But anyway, let's take one step at a time. Again, as we see here, high carbon monoxide, usually it's inefficient cooling and overloading. But there's another thing that could be happening. Carbon monoxide, it could be also a consequence of some overheating of the core of the unit, which that could be again a consequence of abusing the unit. The high oxygen content, again, usually it's a consequence of some moisture in the unit. Again, water is H2O. So, and again, if the water goes into the oil, we're going to find some oxygen and some hydrogen. So, what do? We got to try to find if and indeed this water is coming in, and then we have to find the source and try to fix it. The other thing says low level acetylene. Again, acetylene, it's always a sign of arcing. In other words, unless there is an arcing in the oil, there's no acetylene. What is this arcing could be coming from? As it's written here, could be a motor, or could be some. Another thing about the core, if there is a multiple core grounds, there may be some arcing into the lamination and create acetylene. In this case, the acetylene will be very, very low level, 100 parts per million. And again, that depends upon how many gallons per minute, how many gallons we have in the tank. So, but again, acetylene is always something that gets a worry because again, it's an arcing. Could also be item 4 says could be an LTC. A low tap changer. We have two types of tap changer. One has got an arcing tap changer. The other one has got vacuum tap changer. The vacuum tap, there shouldn't be any arcing, but the LTC, there should be arcing because that's the way they're designed, the arcing type. And sometimes there's a migration from the LTC compartment to the main tank. And there we can find some minute part of acetylene in the main tank. So, and again, that's what we do. We open up the tap changer, we drain the oil, of course. We open up that changer, and then we check the arcing and so forth and so on. And we keep an eye on the main tank too. Item 5, high moisture content. It's the GA. Again, that's the consequence of something that gets into the oil. And if we look, gaskets, again, gaskets is the only means that we have to seal when we have two surfaces in contact to each other and prevent the water or moisture going in, but also condensation in the unit can create some moisture. Because again, the unit will cycle through the day, high temperature, low temperature, and that creates some moisture that gets pulled off the fluid that's in the unit, like oil and so forth. Leaking air cell, that's another, well, what is an air cell? The purpose of the air cell is to prevent atmosphere to contact the oil surface. So if the air cell is defective, so we have some oxidation on the oil because again, it's not being protected, and that's when we have some moisture content in it. Item 6 says acetylene detected by LTC. Again, probable case vacuum bottle failure, because in theory, if it's a vacuum type of LTC, low type changer, there shouldn't be any arcing in the unit. But if the vacuum interrupter is failing, that means that the main contact is opening under load, so is arcing in there. But again, in this case, the acetylene will be detected in the LTC compartment. And again, if there is some tracking or some crack in the board, then we're gonna have this oil migrating from the LTC compartment on the main tank. So, am I going too fast or?
No, good. That's good speed.
Okay, okay. And the second transformer oil title confirms what I just said. You know, oil contamination from the main tank into the from to the LTC by migration. Again, don't forget, the oil can go from one tank to another, but usually it goes from the main tank to the LTC compartment because, again, the pressure in the main tank is much higher than in the LTC compartment because, again, the high volume oil in the main tank. So, but again, gas is funny; it can travel either direction. So, and that's the reason why if the amount of gas in the main tank is not that much, and for instance, the and we got plenty of gas in the LTC. Again, common sense says drain the oil, but again, in that case, we have to turn the unit off, and we got to go look at the tap changer. So the oil temperature alarm, again, what creates the heat in the transformer is the circulating of the current into the current into the coil. So if the current that we circulate into the winding is a lot higher than the winding was designed for, the copper is going to start heating, and again, and it start heating. The next thing you know, the oil is going to be showing high temperature, and again, and that means that there's not enough cooling in the unit at the current we're carrying. If we're carrying the correct load, now it could be a faulty fan motor, like it says, or there's no flow between the radiators and the main tank, or there is some blockage, or there's some in other words, there's some limitation for the oil to do its job. So, and that's why the alarm goes up. Could also be the gauge and then the temperature gauge, and that's what we got to investigate. Oil accumulation around the control cabinet. Well, oil, that's the beauty about transformers. If there's a leak, we got to find on the pad. So, and the inspection of the transformer tells, hey, something is happening here. So what is the oil coming from? It could be, of course, gasket leaks, or maybe too much pressure on the oil on the transformer that it pushes the oil through the gaskets. And again, we had to inspect and replace the gaskets if it's in the gasket. Or again, first thing I would look for it would be the pressure in the tank. Those transformers, especially the one with nitrogen blanket or the one with no atmosphere system, they are designed to work about maybe 5 to 6 psi, which is normally that's what happens in summertime. But again, gasket leaks usually is the source of this oil on the ground or around the control cabinet or wherever. The beauty about oil is that it doesn't go away by itself. So if there is a leak, it stays there even after a couple of months. So a visual inspection tells us what's happening to the unit. Number 4, bushing oil level is low. The high voltage bushings are the ones that they have a dome with the gauge, with the set gauge on the dome. And that usually they're yellow, and usually there's enough oil in there. But if that oil level decreases to a reason, usually this bushing, which is usually the ABB oil type O plus C or the old GE type U bushing, they are sealed. In other words, at the bottom of the bushing, there's no basically any oil from the main tank can go into the unit, into the bushing. So if there is low level in the bushing, most likely there's a leak in the bushing itself to be investigated. 5, low oil level and no leaks. Yeah, faulty gaskets, overloading. Again, the overload creates high temperature. The high temperature creates pressure, and pressure had the tendency of pushing out oil from all the emitting surfaces are. So, item 6, contaminated oil. Yeah, again, what can contaminate the oil? As we said, leaks or infiltration of moisture by other reasons, or again, the oil doesn't. Also, age of the oil tells us that something is happening to it. So, and again, we're gonna inspect for oil pumps, leaks, and so forth. Anywhere there is a two metal surface or metal and a porcelain surface meeting, there is a gasket, and that's a source of a leak. This is very, very interesting. Item 7, low oil level for sealed conservator system. We, GE, used to call them atmoseal system, which means a sealing to the atmosphere. In other words, what the system does, it prevents, as I mentioned before, atmosphere contact oil, because again, they oxidize it and create nasty stuff. So, what the air cell does prevents any oil whatsoever to be in contact with the atmosphere. But if by any chance this air cell generates an opening or a hole or something, now the oil in the atmosphere tank is going to be pushed in the air cell, which the air cell is going to be heavier, is going to drop to the bottom, which is going to push on the arm of the liquid level gauge, and that's going to show that it's a low level. That could be one source. And also, again, it could be some leak that we will find as walking around the unit and finding on the grounds or on the base of the transformer. 8, oil temperature alarm. Again, what tells the gauge to go up is the high temperature of the windings, which heats up the oil, and that's how the temperature goes up. Usually an oil temperature on a large power transformer measured, it's 0 to 120 degrees C. For the winding temperature indicator, usually 0 to 160 degrees C. So by looking at the gauge, we know if it's a winding temperature or oil temperature indicator. But again, the heat doesn't care. I mean, if the oil goes up, is because also the winding went up for overloading. Also, again, poor cooling circulation will create the problem. So, and again, replace the radius valve and gasket if indeed that's the cause of it. Gauges and alarm. Again, we put the gauge. That's the only way we can keep an eye on a unit and see what's happening. Needless to say, if the gauge is cracked or so forth, stuck needle. That's another typical problem, that being these gauges on the outdoor and subjected to the moisture and dirt of the air and so forth, most of the time the needle gets stuck and doesn't show any changes. That's to prove that something is wrong. I mean, it's very seldom that a temperature or anything stays the same all the time. As a matter of fact, item 2, pressure vacuum gauge is 0. That's another thing can never happen, because again, if the transformer tank is sealed, then there will never, very seldom be a zero, be either positive on summertime or be negative on wintertime. If there is a zero, rest assured that either the needle is stuck or the gauge is defective. So the nitrogen pressure alarm, this is a case where a transformer has got a nitrogen blanket on the tank. In other words, here we go. To prevent atmosphere to touching the oil, we put the nitrogen blanket. Nitrogen is an inert gas that does a beautiful job. Now, if and again, they should work. The nitrogen gauge, pressure gauge, should work in a consequence what's happening in the main tank. Again, if the main tank has got high pressure, then the vacuum gauge should bleed out the excessive gauge, the excessive pressure. If there is on the vacuum, then the vacuum gauge should let the nitrogen go inside the tank. In other words, there should always be a blanket of nitrogen in the tank. And if that doesn't happen, and that acts funny, is because something is wrong or the adjustment in the gauge is inappropriate. A power and voltage. Okay, capacitance increase. Usually these two terms refer when we do double testing and referring to the unit. What can make a capacitance of a unit change? Again, a capacitor is nothing more than two electrodes, and in between there is an insulation. That's what's happening to the transformer. If this insulation goes bad, because again, moisture or deterioration or aging, the capacitor will increase, and we'll learn on the double test. And again, that's typical. Not only the capacitance will increase, but also the power factor will be increased. And again, there are gauges, and the gauges are doing funny things. Well, we have to investigate. And if indeed we find that the power factor, that the gauge is not doing its job, again, now it's the time to replace it. But again, these are all symptoms that tells us something is happening in the unit. Testing, high winding resistance. Well, this is very important thing. Usually there is a de-energized step change on these large power transformers. And the de-energized step change is nothing more than a means that tells it to change the ratio on the primary side, the de-energized side. And the problem is that these are usually the stationary contact and the movable contact. They are one pressure against the other. And the pressure, what does, it displaces away the little bit of oil they used to be cooling down the contact. So that's why we recommend at least once a year when we can shut down to operate the energized step changer, because that will replace the thin surface of oil that keeps the contact cool. So also could be that like it says here, coking. Again, if there is a poor contact, there's going to create some carbonization there, and it's going to build up until that. And again, the carbonization will increase the value of the resistance. So, and again, we have investigated why, but usually that's what happened. Okay, non-OSHA approved fan guard. Okay, in the past, we didn't have any concern about people going in the field and putting their hands into the fans while the fans was running. And then OSHA came up and said, hey guys, 1972 or 78, they said, you better have a means of preventing anybody to sticking their hands in the fan. So, and again, OSHA said that the concentric circle of the fan have to be of the ring making the fan has to be at least half an inch, no more than half an inch apart. So, and also they cannot be no more than 6 feet from the ground. Again, got to be at least 6 feet from the ground. That's what OSHA says. And again, you don't have to change the fan, but we on our G transformers, we can replace the fan guard. Abnormal operation of LTC. Again, what operates the LTC is what we call the line drop compensator. What this does, senses the load, and the operator says, hey, if this load or this voltage changing more than 10, 15 volts in so long, and then we got a timer, then you change the tap. Now, if the operation of the tap changer is too close, most likely it's because the timing that we set is not good enough. But again, it could be also, as it's written here, an LTC control. But again, these are things that could be investigated, like mechanical control components. Again, we spoke about the rust of vacuum of water accumulating. Here we go. A control cabinet usually is what we call a space heater. What this does, it prevents a condensation in the control cabinet, and sometimes that for some reason gets turned off, and now we start having some funny things happening. Condensation that summertime gets very hot, and humidity and so forth and so on. The heater has a purpose of limiting those factors. So, and that could be the cause. And again, of course, if there is here we say, if we find that if the heater element is not doing its job or it's not connected, maybe we should check why it's not. This is very important. No circulation between the radiators and the main tank. Again, there should be no variation in temperature in between, correct? The level of the oil at 25 degrees C should be half away of the opening of the top radiator's manifold. In other words, if I have the manifold of the radiator on top, on the bottom, that is about 5 to 6 inches, the oil level at 25 degrees C should be at least half away, 3 inches. Now, depending upon how many time we take an oil sample and so forth and so on, if the tank is very small and we take a gallon of oil each sample and we do not replace it, this level is going to be below the opening of the manifold. So therefore, the oil is not going to circulate, and the oil does not circulate, it's not being cooled down. In that case, we have that the main tank has a much hotter temperature than the radiators. That's a symptom that the oil is not circulating, and that's terrible because again, no circulation, gets hot, gets pressure, start blowing oil through the gaskets. Okay. Questions?
Well, thank you, Nino. Very
again, if I've
very
been too
informative.
fast, because again, I only had a half an hour.
Right, 50 years combined into half an hour is a difficult task. So, well, I think Rachel will chime in and tell the attendees how they can submit their questions.
Okay.
Yeah, absolutely. So if you do have any questions, please submit them in the chat bar. We do have a few currently, so I'll read those off, but please feel free if you do have any questions to just go ahead and put them in the chat and we'll try to get to them. So our first question is, approximately when did OSHA change the standards on fan guards? How old of a fan unit would be a concern of not meeting current OSHA standards?
And okay, again, in the late 70s, only because again there was a lot of incident of people willing or not willing were getting hurt, and OSHA said, hey, we got to make it a way that you cannot. And again, it was a middle 70s, and also said OSHA said that if they are at least they got to be, not to be OSHA guard, they got to be at least 6 feet above the ground level, because again, usually 6 feet or above, people can put their hands in where they shouldn't do it. So again, the answer is middle 70s. And again, as I said before, we do not have to replace the fan assembly. All we have to do, we have to replace the fan guards.
Wonderful, thank you. Our second question is, are replacement analog gauges, like the pressure vacuum gauge, still available? Seems like everything is turning digital.
Well, and that's the beauty about having all the GE records. I mean, lucky for us, we have whatever Pittsfield built, we have records. And what I normally do, and again, you cannot arbitrarily change an analog gauge to electronic stuff because again, there's a lot of changes to occur. So since I have the old design and I go to the original transformer assembly, see what was there. And again, I am sure that I can find a cross reference to something that's analog that fits. May look a little bit different, but it will do the same job and it will fit in the same location, and will do the same job of the original one. No, we are not trying. We do not try to convert the analog gauges to electronics or solid state again, because again, the electrical wiring most of the time will not allow that. So we have to go back to the original one and duplicate the new one. But again, in order to do that, it's mandatory for us to have the serial number of the transformer.
Wonderful, thank you. We have another question. Can you elaborate on the term or purpose of vacuum bottles?
Say it again, dear. What is
We
the
had a
question?
question that says, could you elaborate on the term or purpose of vacuum bottles?
Yes. In the beginning, the majority of load tap changers, what's the purpose of load tap changer? It is a means that the genius in the past created to be able to change the ratio of the transformer under load. In other words, not to de-energize the unit. So, but unfortunately, by doing that, we came up with a dual contact system, which while one was moving to the next step, the other one was still carrying current. So we had to interrupt the current, and by interrupting the current, there was an arcing, and that arcing was occurring into the load tap changer compartment. And then we said, hey, if I have this arcing occurring onto a vacuum interrupter, now I won't be contaminating the oil. And now, we call a vacuum bottles, it's in effect a vacuum interrupter, which means that's where the arcing occurs on the vacuum. In other words, in theory, there shouldn't be any arcing on the vacuum because there's no oxygen to burn. But anyway, that's the vacuum. See, we call a vacuum bottle, but in effect is a vacuum interrupter, which means the interruption occurs on the vacuum. And that's the reason why we have what we call, when we talk about load tap changer, we have two kinds. The arcing type, which is the one we had before, and the vacuum type. The vacuum type is the one, the latest design that we came up with. So vacuum bottle stands nothing more than vacuum interrupter.
Wonderful, thank you. Our next question is, does PSC sell fan guards for older transformers that may not have a guard? If so, are they installed easily?
Well, there won't be a fan without a fan guard. GE never built a fan. See, the fan guard is an assembly of three things: fan motor, fan blade, and fan guard. There won't be a fan motor without a fan guard. So, yes, there is a fan guard that could be replaceable, but again, we need to know where we're coming from. Where do we start from? We can design anything provided we got the original design. And again, on non-OSHA fans, all we have to do is just replace the guard, but we have to know what type of fan we have. See, we have a different size. We have a 10 inches, 12 inches, 16 inches, and 19 inches, 24 to 26. So we need to know where we're coming from. And again, I repeat myself not long enough, whatever we ask for, we need the serial number. And that will tell us three things. First, where was the unit built? As Fred said in the beginning, we had see, Pittsfield was building everything in the beginning. And then 1953, we opened up Rome. Rome took the 40 MVA and below. And then we went to Hickory, and then we went to Shreveport. Now we go to Mexico. But again, Mexican transformers are very different than ours in a way that they have their own design. But if it's a GE transformer, it's again US G transformer. It's mandatory for us to know the serial number of the unit. That tells us where the unit was built.
Wonderful. Thank you, Nino. We have a few more questions.
Yeah.
The next question is, do you recommend online combustible gas motors like the Hydran 201?
Everything that tells us more what's happening to the unit is helpful. I mean, so let's see, the Hydran was a means that after we learn a lot about the gas in oil, of course, we have to come up. There's a machine that the Hydran that I think was one of the first one, and was telling us yes, there's gas in those days, and again, we have to take a sample, we have to analyze it. Yes, anything that tells us what's happening in the unit is always positive. And again, doesn't matter how we read it, as long as we read it.
Thanks,
But one
Nino.
thing I want to emphasize, and maybe not long enough. Again, I am the old generation where you walk around the transformer and you learn much more than is telling us. But anyway, today with electronic stuff or solid state stuff, we have a tendency of having all that information sent it to our computer.
Great. Thanks, Nino. Our next question is, what is the issue with type U bushings? Are there any particular tests to identify if failure is imminent?
Again, I am an old GE guy, and anyway, the type U bushing, there was some problem that were discovered in the paper. Now, like any other bushing, I don't care if it's an O plus C or type U, the best thing to make sure that the bushing is on its job, especially in the high voltage ones, I mean, the double test it. That will tell us. That will tell us what's happening. And again, the change in power factor and capacitance, that's something it's happening to that insulation. Now, we have in the field type U bushing that have been there for 50 years. And again, I don't want to be partial to GE, but I'm waiting to see if the type O plus C lasts 50 years in the field. So, but again, not to be partial to anything, the best thing to do, test the bushing, which, it's a pain in the neck because again, the transformer is energized. Nobody wants to do that. Though nobody wants to de-energize the unit, but if you have a flat in the car, it won't change by itself. You got to stop, remove the wheel, and do the job. On power transformers, again, it's very important that we take care of the stuff.
Wonderful. Thank you, Nino. And this is going to be our last question. So, do you recommend putting bands around leaking flanges, then drilling and injecting with sealant to stop leaks? Or is it just easier, safer, and better to break the joint and install a new gasket or seal?
And again, personally, I don't like patch job. Personally, I always recommend to do the job right. And the only way to do a job right, bite the bullet, turn the unit out, replace the gasket. Because again, yes, there will work, there may not work, but and there's another thing we don't want to understand, anytime we put aluminum or any type of material around the bushing or around anything, we may make it more problem. Yes, the problem that thing may work, but again, it's just like a Band-Aid. Band-Aid won't last forever. If the gasket is done properly, it may last for 20, 30 years. And again, is not, I agree, it's easier and it's quicker to do injection on where the leak is. It's easier, it's quicker, it's less painful. But again, do I recommend it? I'm the old generation where he says if it's broken, fix it right.
Thanks, Nino. All that information is really helpful and great. So I'm sure that a lot of people have gained a lot of additional knowledge from it. If you guys have any additional questions, you can feel free to contact us or our sales team at sales@pseparts.com. Nino also has some contact information as well if you want to go to the next slide, Nino.
Okay.
And
Do we have?
yeah, and we can provide that to everyone just in case somebody has any additional questions after the webinar. We have recorded the webinar, so we will be sending it out to everyone. We also, if you guys have any ideas of different topics that you would like to cover in upcoming webinars, please let us know because we want to help our customers as much as we possibly can. So thank you everyone who attended today. Nino, do you have any additional words before we go today?
Oh yes, whenever you deal with high voltage stuff, be careful, guys. Does not forgive.
Awesome, thanks, Nino. Fred, did you have anything before we go today?
No, I would, you know what, I would just like to thank Nino for offering up his services for this webinar and his years of experience. And, you know, he's a wealth of knowledge, so let's, you know, take advantage of it while we can. And he's gracious enough to enjoy the business and keep at it. So we appreciate that. So thanks, Nino.
Thank you. Thank you very much, guys. Thank you for your time.
Yep, thanks everyone. Hopefully you have a great day and a great Western week.
Thank you.
Bye everyone.
Thank you.